Hello, and welcome to the first video of AP Physics C. The good news is you did all of this in AP Physics 1. In fact, your entire first unit in AP Physics 1 is this one video for AP Physics C. So, as reminders for these vocabulary words, distance is how far you actually traveled. Displacement is how far you are from, the starting point. So, if we start here and end up here, go from A to B, let's make up numbers that this is a distance of 10 meters. This would also be a displacement of magnitude 10 meters, but displacement is a vector, so it also has a direction. Let's go with east for this particular one. So remember, distance scalar, displacement vector. Now if we do a different one, so if we go from C to D, this might be a distance of, using that same scale, 50 meters. But our displacement, shortcut, start to end, that looks like only about 5 meters southeast. So distance, how far you walk, how much exercise did you get, how many steps are on that Fitbit. Displacement is the shortcut. Okay, then we go into speed and velocity, and they're directly related to distance and displacement. But let me slide the notebook up. Here we go. So speed is distance over time. Velocity is displacement over time. So if the distance and the displacement have the same magnitude, then the speed and velocity are going to have the same magnitude, but velocity will have a direction. So if you only travel one direction, then your velocity is speed in a particular direction. But if you do the crazy wiggle path, your speed will be that total distance traveled. So maybe you do this, maybe this is your crazy racetrack, and so maybe you're going 100 miles per hour around this, but your velocity would be the shortcut. It's the same amount of time in both cases. So this would be using the numbers I made up before, because the displacement is a factor of 10 smaller. Your velocity would be a factor 10 smaller than the speed. We don't usually write an equation in symbols for speed as distance over time, but we will for velocity. So displacement, change in position. So remember, the triangle is the Greek letter delta, and it always means change. And you always do final minus, let's actually write out the word, initial. So velocity turns into V, and I'm going to put a little AV here for a reason we'll talk more about that later. That's for average, is displacement, or change in position, over the time interval. We really, in this course, this delta T becomes very important. We just wrote it usually as T last year. So change in time meaning change in time on a clock. So if I say you travel from mile marker 10, or let's see, you're located at 10 meters on the x-axis, and then you go, so that's your initial position, and you go to x equals 50 meters in 3 seconds, that is your time interval. If I say instead that you pass here when the clock says 1.0 seconds, and you reach this location when the clock says 4.0 seconds, then you would subtract those to get the change in time is 4 minus 1, or 3 seconds. Really 3.0 with the way I wrote it there. So most of the time it's written as a time interval already. So we usually read this as time interval instead of change in time. But occasionally you'll have clock times, and then you have to subtract to get the time interval. So this is the average speed, because this is the speed, essentially, this is the average velocity. It's essentially the speed it took you to do the shortcut. Instantaneous velocity is the velocity at that exact instant of time. So in your car, your speedometer basically tells you instantaneous velocity. So maybe you're traveling you're stopped, and then you're going at 20 kilometers per hour, and then you're going at 50 kilometers per hour, and then you slow down to 10 kilometers per hour, which is really slow. But so at any point in time, you're going these 4 different velocities. Your average for the whole trip would be somewhere in between all of those. It would depend on how much time you spend at each of those velocities. So it might be, well, it would definitely be your displacement over your time interval. And then for this particular example, it might be approximately, 22 kilometers per hour. I'm just making that up. But it would be someplace in between all of these numbers. And again, it would depend on how much time did you spend at this speed versus how much time at this speed. We will come back to instantaneous velocity later.